Welcome to Spring LIB.
So we have this uniform 4.5 kilogram gate that is square and has 1.5 meters on the side. And it hangs vertically from a frictionless pivot at the center of its upper edge. So we have this pivot here, and I guess it's hanging down like this. And we have a raven that, I don't know, for some reason, comes in and hits it and bounces off. Now we can figure out how much damage the raven does to the raven. But anyway, the raven hits this thing and it bounces off, and it hits it halfway down. It's initially coming in at 5 meters per second, and it goes out at 2 meters per second. It bounces off. So this is a classic conservation of angular momentum problem about take angular momentum about this point O. And so initially, it's just the angular momentum of the raven before the hit. So it's h over 2 times the mass of the raven times the initial velocity. And then afterwards, it's the door is moving, or the gate is swinging now. So this is just a second afterwards. The gate starts to swing, and the raven is now rebounded off of here. The mass moment of this gate about this axis here is 1/3 m1h squared. So we have basically this, and we can substitute this in. So we get, h over 2 m2 v naught equals 1/3 m1h squared omega plus h over 2 m2 v1. Now, you get an h that cancels out everywhere. We can multiply through by 3, and then we can solve for omega, which is what we're looking for. And so omega turns out to be 3/2 m2, so the mass of the raven, times the change in velocity of the raven, so that's actually going to be 7 meters per second because of the bounce. And then we get divided by m1 over h. So again, as m1 goes up, we can see that omega goes down. So it's not going to move as much if it's heavy, this gate. If m2 goes up, it's going to move more. And in fact, if m2 is 0, then if the mass of the raven was 0, then basically it's saying that the raven just doesn't hit it. There's nothing hitting, so there's no cause for motion. Again, if this goes up, this goes up. If the magnitude of this goes up in the opposite direction, then this goes up. Plugging all the values in, we just get 1.71 radians per second. That's how fast this gate is now swinging after the raven has hit it and bounced off.